Today, we're going to look into the tools needed for building hardware startup, like hardware tools and software tools for prototyping and product development. Hardware startup is vast. It could be consumer electronics like smartwatches, IoT devices, or e-mobility like two-wheelers like scooters, four-wheeler like cars. It could be ceiling fans. Yes, I'm talking about Atomberg, robotic systems, space tech, and so on. If you boil down their core technology, typically you can categorize these startups into three main fields, one being mechanical, electronics or electrical, computer science for programming, firmware development, UI, UX, and so on. So let's look into these one by one. Let's get started. What's up everyone, this is Karthik Rangarajan, founder and CEO of Agam Robotics. Hope you're doing well, come for the drones and stay for the prototypes and the added frustration of manufacturing in India. Yes, I had to wait for another couple of weeks before I get the prototype boards in my hand for testing. Totally understandable, but that sucks. And this is typically going to be part of the manufacturing process in India. I hope things get better in the future, and specifically for hardware ecosystem in India. This is one of the reasons you see like a lot of the product launches getting delayed because of supply chain issues from hardware startups like EVs or anything hardware related in India. There's chip shortages everywhere due to the pandemic. The after effect is still there. It's not just in India. That's global problem, and it's getting better and better, but it's very slow, and the impact is going to be there up until like next year, it feels like. So let's look into the tools and let's get started. All right, let's look into the first one in the list, which is computer-aided design, CAD. For mechanical, it's called mCAD. CAD software enables you to create detailed digital version of your product or parts. It allows you to design individual components and assemblies. You can specify dimensions, you can apply materials and textures. Popular CAD tools include AutoCAD, Fusion 360, SolidWorks, PTC Creo, and so on. The personal one I have been using is Fusion 360, and I've been using that software for like almost 5 years. I don't use like any other alternatives, and Fusion 360 provides a really clean user interface. The functions and features are like categorized neatly in the user interface, and let's look into it. So this is the user interface for Fusion 360. As you can see, there are projects on the side and all the tools and functionalities on the top. And you can select, depending on your requirement, you can go with design, you can create like renders, you can do animation, simulation, manufacturing process, and drawings. And on the top here, there are multiple tabs for each functionality. These are for solid objects. There is surface, mesh, sheet metal, plastic, like in case of injection molding, you have all those functionalities. And utilities include a lot of other functionalities, including 3D printing. This is something which I like doing it. And 3D printers are really a necessity for hardware startups, for developing prototypes and so on. Like 3D printers have reduced the rapid prototyping stage, wherein like you don't have to send files to manufacturer and wait for months. I hope such technology comes for PCBs too. So let's look into the design here. Let's not dive into every functionality and features of the software. We are just doing an overlay of what the software can provide. So I've already created a function. There's a project created here. You can double click it and you can create designs right away. Let's not get into in-depth design. Let's look into a simple model. So first I would like to create a sketch on this surface, and I select R on my keyboard to generate a rectangle, and you can choose what type of rectangle you need, 2-point or center rectangle. I select center rectangle with the dimensions of 100 over 100 and hit enter. Now you can see that there is a sketch of a square of 100 by 100. So this is just a 2D sketch, and we haven't created a 3D model. To create a 3D model, we need to sort of extrude this sketch. So I'll select this and hit E on the keyboard and extrude as much as I need. So I'll select 100. I get like a 3D cube over here, as you can see. Pretty easy, right? And now I want to make this hollow. So there are a lot of functions and features over here. So there is a function called shell. You can select that and select the surface you need to make it as hollow, and you can specify the dimensions as like 5 or 10 millimeters, and you get to see the hollow within the object. You can specify the dimensions, or you can drag the arrow. So I'll just like hit 5 millimeters and hit enter. So as you can see here, like I created a model here. And in some cases, you may not need sharp edges. Like if you're 3D printing or injection molding, sharp edges are not ergonomic. So what we can do is you can select fillet here, or you can also select the hit the keyboard shortcut F and select all these edges and specify like 5 millimeters, and you can see immediately it gives a curved edge. And you can also do the same thing for the bottom. The thing is here, because of the curve, once you press F, it's going to select the entire region of the base. And you can hit 5, or let's do a different thing here. Let's enter 10 and hit OK. Now you can see it's all like curved edges everywhere. You can also do that on the top surface here. You can hit F and you can make the same thing. And you can also do it inside to make it stronger. If you're like 3D printing, you may not have like a really strong base, so you can set it to like 10 millimeters. Now it looks good. The functionality, what I like with Fusion 360 is that you can go to utilities, and if you have a 3D printer connected to the computer, you can select 3D print, and once you select the object, you get the dialog box here, and I've already linked my slicer software, which is Ultimaker Cura, and once you hit OK, it would open up in a separate application. And once you save this file, you can name this cube and hit OK. You should be able to see that saved object or the file over here. And I think we should pretty much see Cura over here. All right, you're seeing the object on our 3D printer. So this is the Cura software from Ultimaker. I've already set up the 3D printer what I have, which is V2 Neo, and I have like all the material settings and print settings over here. So once you have your object in the 3D printing hit slice, and it should start the slicing process, and you can go to preview, or once it's done you can select that over here. You can see your object is sliced by the 3D printer, and you can see all these objects being in the layers. So once you slide down these layers, your 3D printer is going to print layer by layer. So 3D printers are really necessary for prototyping. So they are used to create physical prototypes by layering materials with like plastic or resin and so on. As you can see here, the 3D printer what I've been using, it's printing an object by depositing material layer by layer. They enable you to transform digital CAD models, what we saw on the file we created, into a tangible physical objects. Something like this is going to be created by the 3D printers. So these are really cost effective, and it increases the prototyping time. There are more resources available for 3D printers. If you want me to explain in separate video, please leave your comment below. You can use laser cutters, which has a focused laser beam to cut or engrave materials such as like wood, acrylic, or metal. They are useful for creating like custom parts or enclosures specifically for your prototypes. In cases like where there's a bigger panel or enclosures, you cannot print on a 3D printer. It would consume a lot of material. At the same time, you need a bigger 3D printer, which costs higher, and also it takes longer time to print. So in those cases, you can use laser cutters to shape or cut your acrylic or metals. All right, next in the list is electronic design automation or EDA software, which is also called eCAD. electronic CAD, computer-aided design. EDA software or eCAD is used to design and simulate electronic circuits and PCB layouts. These tools offer a range of features like schematics, component libraries. You can create circuit simulation, PCB layout. You can create like circuit diagrams and place components on a virtual board, just like how we saw the mechanical model and it created a physical tangible product. You can do the same thing with the electronic design. You can create circuit boards in a virtual world or in the software, and you can, once you know like everything is good, you can send those manufacturing files to get it manufactured. As I said, we don't have the technology to do it at home. We do to some extent. If it's like a simple board, we can actually get a 2-layer PCB boards and do it in-house, but it also requires a lot of chemical process and so on. It hasn't been simplified as much as a 3D printer is. The tools which are required for this are Altium Designer, Eagle, KiCad or KiCad, or as some of them pronounce it. These are the commonly used electronic designs. I personally have been using KiCad and Altium Designer now. I switch back and forth based on the requirement. So this is the user interface for the Altium Designer. On the left, you can see the projects I've been working on, so it's blurred. And this is the schematic sheets. And on the right, you have all the properties. So I've already created a project. I just wanted to show with the IMU, which is MPU 6500. This is a chip very similar to what you have in your smartphones when you change your phones from landscape to portrait mode, or if you have like the auto rotate feature on. So how you switch or how the phone switches from landscape to portrait, this is what is going to do. So this chip is the one which is doing that sort of functionality. So once we go to the component section here, I can type in MPU 6500, and it looks like the component is not there in my library. So I can click here, find in manufacturing part search, and it searches in the global database, and in here you can see the part is available. So I can right click and hit place. It's going to generate the symbol. So what the symbol really does is, just a minute. So this is the data sheet for MPU 6500. So if you check this data sheet, it has all these information as the pinout diagram and symbols and like typical schematics diagram what it needs. So this is the real component, or I should rather say, let me go back. So this is the real component, and you can see all these pins which needs to be soldered on the PCB board, what we designed. So we need to create 3 things here. One is the symbol where it has all the pin outs, like just this. And then what we need is the footprint of this part, where this component is going to be placed onto the board. We need all the footprints of this design. So we are going to do all those 3 things now. And the third one is being the 3D view of the component. So this is the schematic, and you can see all the pinouts being generated automatically in the global library. In some cases, if you're working on a very specific part which is not available, you can create these symbols by yourself in the software. So here you can see there is the symbol and the 3D model of this component here. I can zoom in and I can hold the shift key, and you can see there is a footprint. This is what I was talking about. And these are the symbols. So in this case, it's already been generated in global library. Most of the parts would have it. If you are like into a specific parts which are not generic, like resistors, capacitor, ICs like these, there are certain processors or like microcontrollers you might have to create your own. We can look into that in depth in future videos maybe. So let's refer to the data sheet, and let's not get in detail again here. I just want to show you how these softwares can be used. So let's do one thing. Let's create this circuitry here on the 13th pin. Let's attach a capacitor which is 0.1 microfarad. So let's search for capacitor. Or you could just do that here. We need 0.1. Is that what it said? Yeah, 0.1. So let's select. Oh, where did it go? Okay, we have like an 0402 to pin 13 right here. So I can just drag and place it over here. I can place how many ever I need, and you can hit escape and you can select all, delete it. So now what we'll do is we need to connect pin 13 to this capacitor. So the shortcut key for this is Control W for wire. So you're attaching a wire to these two, and the other end goes to the ground. So where you can search for the ground is over on the top here. You have the component placement. You have like wire over here too, or you can use the shortcut Control W. And what we need is ground. So let's select this, place ground, and click over here. So now we have created a circuit closure for pin number 13. And you might have to do the same for each of these pins. So now that we did this, you can hit save. And I've also created a PCB doc file here. So what you can do is you can update the schematics into the board. So how we do it? We can go to design, press update PCB document. So once you click that, it's going to generate a change order. You can click execute changes. And once it does, it checks everything and hit close. You can see the footprint already being generated into the board. So now this is the actual footprint which is going to be on the PCB. Like if you have seen certain PCBs, not with the components, without the component, this is how it's going to look. So you have this same process over here. So this is the PCB document, but the question here is, we don't have anything connected. Even though we have done the connection here, the PCB understands there is a connection between these two, but there is no physical wire attached to it. So how we can see it is you can hit 3 on the keyboard and it changes to the PCB. So you have all the 3D model of the components. This is a capacitor. As you can see, there is no wire connecting these two. So what you can do is go back to the PCB design, which is pressing 2, and you can see that the ground is over here. So you can select the component and press space. You can change the orientation. And now do the same thing, Control W for wire, and I'll select this. You can see the wire trace. This is called a trace on the PCB. If it's a physical wire with an insulation, that's a wire, but on the PCB it's called trace. So once you attach this, now it's linked. So wherever you drag it, it's going to be connected. So this is a very simple connection. Once you have like a really complicated boards, like how we saw on our previous videos, you have like a lot of these components interconnected, and you will have like a complete board. Now, once you connect this wiring and hit 3, now you can see there is a trace connected to this component. Now you can also drag wherever you need, depending on how you need to be placing the components. It's totally up to you to do it. Again, this is really the basic version of the board. We can go in depth if you need it. I'm just giving an example here of what all the things you can do. This is just about the PCB designing. So we don't have to like get in depth, as I mentioned before. Let's move on to the next one. Now that we saw about the simulation of electronics, how are we going to do the prototyping for this? Like for mechanical, we design and we can actually 3D print and get a physical tangible product. So how are we going to do for a electronic circuit? So there are few ways to do it. One is the breadboard, which allows you to quickly prototype and test electronic circuits without the need for soldering. So these boards have a connection between the vertical and horizontal lines, as you see here, and all the red lines are connected together and all the green lines are connected together. You can place all the components, and if there is a place where the components are farther apart, you can use wires to do it, and you don't need to solder. And once you test your prototype and it's all working, you can actually take out the components and reuse the prototyping board, the breadboard. So these features allow you to test out if a design works or not. Again, there are limitations in here. If there are a board design where you're using generic resistors, capacitors, ICs, and so on, you can do it. For a complex board design, you may have to go one step ahead. Like if there is a microcontroller, you may have to solder the microcontroller into a PCB design and have those pins fit into a breadboard for you to prototype. So that's why we have prototyping or evaluation boards like Arduino, Raspberry Pi, and other prototyping platforms, which provides the simplified way to create and test hardware prototypes. These platforms allow you to connect a lot of compatible sensors like modules, the MPU sensor, the IMU sensor, what we designed, we have those boards available. You can connect and test it out immediately with an Arduino or a Raspberry Pi. There are libraries available for programming these components, and this would actually speed up your rapid prototyping. The third one in the list is programming. For programming, it totally depends on what programming languages you use. It could be C, C++, Java, Python, and so on. So there are multiple different IDEs available for it. In some cases, if you're developing a firmware for a microcontroller, you may need software like Keel Microvision. And you can use standard IDEs like Visual Studio, PyCharm, if you're into programming, C, C++, or for Python, you can also do Visual Studio or Visual Studio Code. You can also use PyCharm IDEs. What you see here is a VS Code, which I personally use for programming and developing firmwares for flight controllers, which is what I'm working on. So this is a PX4 firmware, which is under development for the board what we are getting manufactured. So there are tons of tools available here. So I don't want to get into the coding or anything in specific, because it's not common for a lot of other prototyping platforms. As much as the electronics and mechanical is, programming could involve so many different things. If you're using Raspberry Pi, it could be Python, so you can use VS Code, or you can also use Linux-based platforms to do it. So if you have something in terms of developing UI UX, so it could be on a C#, or if you're doing an app base, which is either iOS or Android, so you had to use different platforms to it. Apart from these tools, what we have seen for mechanical, electronics, and programming, there are other tools which may be required for some cases. Physical tools like hand tools or power tools. What I'm talking about is the screwdrivers, pliers, wire cutters, soldering iron, and then power tools drills, for shaping and cutting. You may need Dremel for removing materials, or shaping certain panels, or so on. And you may also need measuring tools like calipers, measuring tapes for accurate measurements and dimensions. Apart from that, for electronics, you may need multimeters for measuring voltages and currents in your board, or much more complex system may need oscilloscope and logic analyzers for troubleshooting and testing electronic circuits. Apart from these, there are other tools, if you're working in a team. By now, if someone is into startup, you may already know what you're into. If it's something in very early stage, you may have to use collaboration tools like Notion or Trello to communicate between teams. And if you had to communicate between people who are working from different locations or so on, you may have to use Slack, Discord, or Microsoft Teams, and so on. And if you are into coding or anything of that, you may have to like use GitHub to have a sync within the system, and so that like everyone is up to date on which is the latest code, and everyone is working towards that. And apart from that, you may also need like cloud storages like Google Drive and Dropbox for creating like documentation, work instructions, and so on. In conclusion, these are the softwares which are very generic and being used in every use cases. But depending on your type of your startup, you may have to choose what you have to go with. So leave your comments below what you think about the tools. And if you have like any other tool suggestions, please do let me know. And thanks for watching.